Hey everybody, you've made it to the fourth and final video for our flipped classroom work here on solving exponential and logarithmic equations. Congratulations, we're almost done. In these three examples that I'm going to walk you through here, and then three that you're going to have to do on your own, we're going to be working with logarithmic equations. At the start here, we're going to be using ones that have quadratic components to them. And what you need to know there is that we have what are called extraneous solutions that might be possible in these problems. An extraneous solution, you guys, is one that you can come up with algebraically through the steps in the problem that might possibly not work because of the domain of log. Remember, we can only take when we have log base b of x, remember, x has to be positive. So whatever we're taking the log of, once we plug it back in, the variable, we want to make sure what we're taking the log of is still positive. If it's an extraneous solution, then it's an extra solution that actually doesn't end up working because of the domain of the problem. So, without any further ado, let's get started here. What I see on both sides of the equal sign is the same log base, so I can start like I started before here with just simply making an equation out of the exponential pieces. So v squared plus 35 equals negative 12v minus 1. Now, because I see a quadratic piece, I know I probably am going to want to think about trying to factor it at least to begin with. And to do that, I have to set it equal to a magic number of 0. So v squared plus 12v, and then move the 1 over would be plus 36 equals 0. I hope you can agree that we're looking for factors of 36 that add to 12. So that's v plus 6 twice. And again, when that's set equal to 0, we're going to get each factor set equal to 0 gives us an answer. So v equals negative 6, and that actually occurs twice. So we're going to see if negative 6 substituted in will work in this equation. So if I think about plugging in negative 6 in for v into that first expression, we know that when I square a negative, I get a positive number out, so it looks like a positive number plus another positive number shouldn't give us a problem. Now this right-hand side has me a little bit worried just because I don't see a squared involved, but let's think about what would happen if I were to again use that negative 6 that I came up with in place of the v. So we'd have negative 12 times negative 6, and then don't forget a negative times a negative is a positive. In this case it's positive 72. That would be minus 1, and that's a positive 71, so we're still in the clear. Both sides check out, so we can say our final answer is negative 6. Please don't say that that's your final answer unless you think through that process of whether it works in the domain of the problem. Okay, take a pause on your video here and attempt example 16 in the same way. You're going to see quadratic pieces, you're going to need to factor, and you're going to need to check to see if you've got an extraneous solution or not. Make sure you check your answer with the teacher and pause your video now. Okay, in this next part of video AM-L2, the second part of logarithmic equation solving, we have equations that we see logs occurring in more than one term, and so we know that what we need to do is that we need to condense these equations to one log on each side of the equation first. In this case, we only have one log on the left-hand side here in example 17. So I need to remember my condensing rules, and my condensing rules say that if I am adding two separate logs, as I am in this case, then I'm going to go ahead and multiply the two pieces that we're taking the log of into one log. So that's going to become the following: log, notice again common base 10, so I don't need to write it, but of 8 times x is going to equal 2. Now in this case I'm going to remember, because it's the common log, if I were to rewrite this exponentially, this would be, and here I'll write in my base 10 so you can see it a little better, this would be 10 to the 2, or squared, equals 8x. So again, remember the definition of log is what does that. It's the base to the answer equals what am I taking the log of. So 10 squared is 100 equals, 8x. And then x is going to equal, if I reduce it, 25 halves, or 12.5 if you want to give it an exact decimal. In this case, it is an exact decimal. So 12.5 is your answer. So pause your video here and see if you can condense another example here, example 18 for your we do example, and check the answer with your teacher when you're done. Take a pause here. Last part of the video here, we have logarithmic equations again, where we're going to need to do some condensing, but you can see that we're using natural logs in this one, or LNs. So on example 19, as we're solving for x, I hope you can agree that we've got a condensing situation. We definitely have a subtraction of two separate logs, which condenses to division, don't forget. So this is the ln of negative 3x minus 1 all over 7, that's the ln of that whole thing, equals just 2. Okay, I'll remind you that natural log, remember, has a base of e. So as I think about undoing this exponentially, it would be base to the answer equals what we're taking the log of. So that's e squared is going to equal that fraction, negative 3x minus 1 all over 7. Now we can use our e button on our calculator and just do e to the 1 and then, or e squared, actually in this case, and get an approximation for that. My approximation for e squared on my calculator gives me this, 7.389, and again, let's go to 5 places until we're done here with our rounding to 4. So we want to go to, say that that is going to be equal to, approximately, the ratio that we had there before, negative 3x minus 1 over 7. Then, of course, to get rid of the fraction, I'm going to need to multiply both sides by 7, so I get somewhere around here, 51.72339-ish. And that is the approximation for 3x, negative 3x, I should say. And then divide by negative 3 is going to give us our final answer for x, which is negative 17.2411. Okay, so that again was using a condensing application for our logarithms, and notice that we are using a natural log in this case, so to undo it we had to do e to the something power instead of before where we did 10 to the something power, or whatever the base was. In this case the base is assumed to be e. So take a pause in your video here and do our very last example. Great work, you guys. After you are done all these examples and they're checked with your teacher, you can go ahead and get started on the you do phase of our lesson, which is a worksheet packet of CUDA worksheets, practicing these exact same concepts. So thanks, guys.